Students are sometimes given problems like, and you're going to see problems like this crop up in many different ways, shape, forms, or manner throughout this entire course. Okay. Here they're saying find the values of x that make the following expression equal to 0. So essentially we're setting this equal to 0. We want to solve the equation. So students will sometimes say, well, how do I do that? We're going to learn momentarily how to handle polynomial equations where all my exponents are integers, positive integers at that. But how do I handle when I have these exponent integers? I mean, these exponents that are fractions on my x's, and I have several different powers of x with these fractions. How do I handle that? Well, you got to look for other means and other ways of simplifying it. And one of the things that sometimes students overlook on this one is that this is actually quadratic. Because what I'm going to do here, because we want to set this equal to 0 and solve for it, I'm going to let a equal x to the 1/5 power. So I'm looking at like the what would be the middle term, and I was like, I'm going to let another variable equal that variable, because along with that, if I were to square a, I would get x to the 2/5 power, which happens to be the other power of x I see involved in the problem. So I can change this over to make this an equation: a squared minus 10a plus 24 equals 0. Now keep in mind, ultimately we are, if you look at the question, it says find the values of x. We want to find x values. If you stop here at the end of this the lines we have here and say a equals 6 or a equals 4, which I got from factoring the a squared minus 10a plus 24, and then using the zero product property to say, well, either a minus 6 has to equal 0 or a minus 4 equals 0. If a minus 6 equals 0, then a has to be 6. And if a minus 4 equals 0, then a has to be 4. If I ended here and say that's my answer, well, no, it's not. Because you were asked to find x values. What you found so far are a values. I got to turn this back and find some x values. So what's going to happen here is I'm going to now turn a's back to x to the 1/5 power. So x to the 1/5 is going to equal 6, or x to the 1/5 is going to equal 4. And then to solve for x, I'm going to have to raise both sides to the power of 5. So I essentially have a fifth root on the x on the left of each equation, and I want to get rid of the root. In this case here, I'm going to raise both sides to the fifth power, and my two answers are x equals 7,776 or 1,024. Those are the values that'll make that original equation set equal to 0.